SpaceX just made the biggest strategic shift in the company's history. Mars, the planet Elon Musk has been obsessing over for 2 decades, has been pushed to the side. The new target, a permanent, self-expanding city on the moon. And the timeline is not some distant fantasy. We are talking less than 10 years. When this news broke, the space community erupted. Some people called it genius, others called it betrayal. But when you actually look at the logic behind this decision, it becomes almost impossible to argue against it. Let's break down exactly what SpaceX is planning, why the moon suddenly makes more sense than Mars, and what this lunar city will actually look like when the first structures start going up. For years, the plan was simple. Build Starship, go to Mars, colonize, make humanity multiplanetary. That was the pitch, that was the dream. So what changed? Nothing changed about the dream itself. What changed was the math. Mars is brutally far away. A one-way trip takes 6 to 9 months. Launch windows only open every 26 months. If something goes wrong, a critical system fails, a supply shipment is lost, you're waiting over 2 years for the next chance to fix it. The moon? 2.5 days away. Launch windows open every 10 days. You can test, fail, fix, and try again dozens of times before a single Mars window even opens. Elon himself put it bluntly in a recent internal meeting. A self-growing lunar city is achievable in under a decade. Mars will take 20 years or more. The moon isn't a downgrade, it's the proving ground that makes Mars possible later. But let's take a step back. Why leave Earth at all? We have everything here: air, water, food, gravity, Netflix. We've got serious problems to solve on our own planet. Why spend trillions building cities in space? Here's a perspective that puts everything into context. The Sun contains 99.86% of all the mass in our entire solar system. Earth? Our planet represents 0.0003%. Every person who has ever lived, every war, every love story, every invention, every species. All of it happened on a speck so small, it essentially rounds to zero. We are voluntarily confined in the entire human story to a fraction of what's available to us. And we're doing it on a planet that could be sterilized at any moment by a large enough asteroid or a supervolcano eruption. Expanding beyond Earth isn't about abandoning our home. Nobody is being forced to leave. It's about making sure that the human story doesn't end with a single catastrophic event. And it starts with building the first settlement that can sustain itself without constant resupply from Earth. It doesn't matter whether that first settlement is on the moon or Mars. What matters is proving it can be done, and the moon lets us prove it 10 times faster. So how do you actually build a city on the moon? The answer starts with one staggering number: 1 million tons. That's roughly how much material needs to be delivered to establish a truly self-sustaining outpost. To put that in perspective, the largest cargo ships on Earth, ultra-large container vessels, can carry about 150,000 tons each. You would need nearly 7 of these ships packed to maximum capacity to equal what SpaceX needs to land on the lunar surface. Obviously, you can't sail a container ship to the moon. You need rockets, and not just any rockets. You need something that can launch constantly, carry enormous payloads, and do it cheaply enough that the economics don't collapse. This is where Starship version 4 enters the picture. SpaceX is currently preparing for version 3 flights, with Flight 12 expected soon. But version 3 is really just a stepping stone. The ultimate goal is version 4, a monster of a rocket standing 142 meters tall, powered by 42 engines, capable of hauling over 200 tons to orbit per flight. The target launch cadence? Once per hour. Let that sink in. Not once a week, not once a day. Every single hour, a Starship lifts off, delivers its payload, returns, and launches again. At that rate, SpaceX could push roughly 4,800 tons into orbit every day. That's 1.7 million tons per year, almost double what's needed for the entire lunar base. Elon has estimated the construction timeline at 10 years. Spread across that period, the math works out to about 500 cargo starships sent to the moon annually. Each one requires approximately 5 refueling flights in orbit, which adds another 2,500 tanker launches per year. Total sustained cadence, roughly 8 launches per day. That sounds aggressive until you realize SpaceX is already building 5 launch pads simultaneously. The infrastructure is being laid right now. Here's where the plan gets truly creative. Not every Starship that lands on the moon needs to return to Earth. Think about it. A Starship upper stage has a dry mass of around 120 tons, mostly stainless steel. The hull is already pressure sealed. The shape is practically purpose-built for a habitat. So instead of wasting fuel to fly an empty ship back to Earth, you lay it on its side, reconfigure the interior, install airlocks and life support systems, and cover the whole thing in lunar regolith for radiation and micrometeorite shielding. The regolith is free. It's already there. You don't have to bring shielding material from Earth. Every Starship becomes both a delivery vehicle and a building. The payload it carries, up to 200 tons of equipment, solar panels, batteries, robotic systems, is designed to outfit the habitat. When the ship lands, the cargo includes everything needed for assembly. Think of it as flat-pack furniture for the Soon, delivered, unpacked and assembled on site. And who does the assembly? Optimus robots. Tesla's humanoid robots riding along in the cargo bay, designed to work in the harsh lunar environment where you really don't want humans doing manual labor in spacesuits. SpaceX's internal concept art showed a base on what looked like a flat lunar plain, but the actual site will almost certainly be at the South Pole, specifically near Shackleton Crater. The reasons are overwhelming. Certain crater rims near the South Pole receive near constant sunlight, critical for solar power generation. Meanwhile, the crater floors contain permanently shadowed regions where temperatures never rise above -230 degrees Celsius. These frozen zones hold hundreds of millions of tons of water ice. That water is everything. Drinking water, breathable oxygen through electrolysis, hydrogen for rocket fuel, radiation shielding when frozen into barriers around habitats. The South Pole holds an estimated 50 to 70% of all accessible water ice on the entire Moon. Shackleton Crater isn't just a good location. It might be the single most valuable piece of real estate in the solar system right now. A manufacturing base on the Moon will devour energy. We're not talking about powering a few lights and a science lab. We're talking about chip fabrication plants, satellite assembly lines, life support for a growing population, fuel production facilities, heating systems to keep batteries functioning in extreme temperatures, and, most dramatically, a mass driver. Yes, a mass driver. an electromagnetic launch system that accelerates payloads along a track and flings them into lunar orbit without using a single drop of rocket fuel. Elon confirmed this in a recent internal presentation. SpaceX wants to build a mass driver on the moon. The purpose? Launching AI compute satellites directly from the lunar surface into Earth orbit. This is the part of the plan that transforms a lunar base from a science project into a trillion-dollar business. SpaceX recently filed with the FCC for permission to operate 1 million AI compute satellites in low Earth orbit. 1 million. For comparison, the current Starlink constellation has about 10,000 active satellites. This new network would be 100 times larger. These satellites would orbit in a sun-synchronous pattern, always riding the boundary between day and night, always generating solar power. Their purpose? Massively accelerating artificial intelligence capabilities by moving computation off-planet. But here's the key insight. If you're building 1 million satellites, manufacturing them on Earth and launching them one by one is absurdly expensive and slow. What if you could manufacture them on the moon using local materials, assemble them in lunar factories and launch them into orbit using a mass driver powered by lunar solar energy? No launch costs, no terrestrial bottlenecks, no environmental impact on Earth. Just a steady stream of satellites being electromagnetically catapulted from the lunar surface into space. If this works, and the physics absolutely supports it, the moon base pays for itself. Not through government funding, not through tourism, through becoming the solar system's first off-world industrial centre. That's why this isn't just an exploration mission, it's a business plan. And when trillion-dollar economics are driving the expansion, the investment becomes self-sustaining. The base grows because it's profitable to grow it. None of this will be easy. Lunar dust is catastrophically abrasive. It destroys seals, clogs mechanisms, and shreds spacesuits. Radiation on the surface, without Earth's magnetic field or atmosphere for protection, is a constant health threat. Lunar nights last 14 Earth days, plunging temperatures to minus 173 degrees, and cutting off solar power entirely. And the long-term health effects of living in 1/6 gravity are completely unknown. Every single one of these problems is solvable. But they all need to be solved. Regolith shielding handles radiation. Battery storage and potentially small nuclear reactors handle the long nights. Dust mitigation strategies are already being developed. Low-gravity health effects can be studied and potentially countered with centrifugal habitats down the line. The point is, none of these challenges are physics-breaking. They're engineering problems. Expensive, complex, demanding engineering problems. But the kind that humans have historically been very good at solving when the motivation is strong enough. Based on everything SpaceX has communicated recently, here's how this could unfold. 2027. First uncrewed Starship landings on the lunar surface. Pathfinder missions testing landing accuracy, cargo deployment, and robotic construction capabilities. 2028 to 2030. Sustained cargo delivery begins. Starship habitats are placed, covered with regolith, and activated. Solar panel fields are deployed. Mining operations start extracting water ice from permanently shadowed craters. Early 2030s. First human crews arrive for extended stays. Not visits, residencies. Engineers, technicians, scientists, and construction specialists living and working on the Moon for months at a time. Mid-2030s, population scales up. Manufacturing facilities come online. The first satellites are produced on the lunar surface. Mass driver construction begins. Late 2030s. The base approaches partial self-sufficiency. It produces its own water, oxygen, fuel, building materials and power. It manufactures products for export. It generates revenue. Is this aggressive? Absolutely. Elon Musk's timelines are famous for being optimistic. But even if everything slips by 3 to 5 years, we're still looking at a functional lunar industrial base within our lifetimes. This is bigger than SpaceX, bigger than Elon Musk, bigger than any single company or country. The first self-sustaining settlement beyond Earth, wherever it ends up being, is the most important milestone in human history since we learned to control fire. It means that no single catastrophe can end our species. It means that humanity's future is no longer confined to one fragile world. Once you prove that a settlement can sustain itself and grow on the Moon, you've cracked the fundamental problem. After that, Mars is a matter of adaptation. Asteroids become accessible. The outer solar system opens up. The entire trajectory of civilization changes permanently. Stay on Earth alone, and we remain one bad day away from extinction. Step off this planet, build something that lasts, and we become something entirely new. A species that doesn't just live on a world, but builds them. And that journey, it starts with a city on the Moon, possibly before this decade is over.